Mini Lesson 1C, Contingency Tables and Venn Diagrams. Become familiar with these vocabulary words. Bias, an inclination, prejudice, preference, or tendency towards or against a person, group, thing, idea, or belief that can be learned or innate and is often subconscious. Attrition bias, when participants drop out, making the remaining group no longer representative of the original sample. Non-response bias, when certain individuals or groups don't respond to surveys, the results reflect only the views of those who responded. Recall bias, when participants do not accurately remember past events or experiences, skewing the data based on current feelings or beliefs. Sampling bias, when the sample isn't representative of the target population, leading to skewed results. Self-selection bias, when individuals volunteer to participate, it often leads to the overrepresentation of more engaged or motivated users. Survivorship bias, when only successful observations are studied, ignoring those that did not succeed, leading to skewed conclusions. Undercoverage bias, when some members of the population are inadequately represented in the sample. Probability sampling methods involves random selection, allowing researchers to make strong statistical inferences about the whole population. These sampling methods usually are harder to do, but also minimize the biases. Simple random sampling. Every member of the population has an equal chance of being selected. This can be accomplished by using tools such as a random number generator. Systematic sampling. Individuals are chosen at regular intervals with only the first participant being selected randomly. This can be accomplished by assigning every member of a population with a number, randomly choosing a starting point and serving every 10 people in the number list after that. Stratified sampling. A population is divided into subgroups. Each group has a random sampling to ensure that each subgroup is represented. Clustered sampling. Dividing the population into subgroups where there is varied data, but it may have one similar common characteristic. For example, group a population by city. Non-probability sampling methods involves non-random selection based on convenience or other criteria, allowing researchers to easily collect data. Methods include convenience, voluntary response sampling, judgment, purposive sampling, snowball sampling, and quota sampling. Although these methods are easier and cheaper to conduct, they tend to include more biases. Here's a simplified formula for proportions. This is used to figure out what sample size is needed for a certain population. The acceptable sampling error is usually 95% confidence level. So basically, the E, the acceptable sampling error, would normally be about 0.05 or smaller if they wanted the confidence level to even be larger. This diagram right here is the accuracy and precision. If we have high of both accuracy and precision, this is what it would look like. If it was low in both, it would look like this. Compare each of those four pictures. On the next page, you have sets and Venn diagrams. these are the different ways of comparing two sets. This is A or B. This one is A and B. This one is either A or B, but not both. It's the exclusive or. Not A and not B. Not A and B. A or not B. Not A or not B. Not A and not B. A set of two distinct things, A, B, and then B is a subset of A. Here's what each of those symbols mean. Here's an example of a Venn diagram that has 4 sets. Let's look at the last page. Contingency tables and Venn diagrams. We have dogs and cats in this table. The percentage that owns a dog would be 5 out of 25. 20%. Don't own a dog would be the rest of the percentage, 80. Now for own a cat, it would be 15 out of 25. $60%. And then don't own a cat would be 40%. 60 plus 40 would be 100%. Those are complements of each other. Now, to own both a dog and a cat, they would only look at this number, 2 out of 25. %. Now, own a dog given that they own a cat, they would only be looking at this total. It would be 2 out of 15, about 13.3%. And then own a cat, given that they own a dog, would be out of 5, 2 out of 5. 40%. And then don't own a cat or a dog would be 7 out of the total 25. 28%. In a class of 28 students, 8 play an instrument and 10 play a sport. There are 6 students who play an instrument and also play a sport. What is the probability that a student does not play an instrument given that they play a sport? First, we want to fill out a contingency table for this. The total number of students is 28. So we'll write here. The total number of people that play an instrument is 8. And the total number of people that play a sport is 10. And then there's 6 students who play an instrument and play a sport. So that would go right here. Now that we've written our givens, we want to find what is left and fill it in before we answer the question. All right, play instrument is 8. So that means this missing spot must be 2 because 6 plus 2 is 8. Right here we need to put 4 because 4 plus 6 is 10. Right here we're going to write 20 because 20 plus 8 is 28. And then right here we're going to write 18. And then we can fill in this number, 16. Now we want to find does not play an instrument given that they play a sport. So there's 10 people who play a sport altogether, and 4 of them do not play an instrument. So we'll say the probability is 0.4, or 40%. A math class had 23 students. There were 13 students who passed the test and 14 students who completed the assignment. There were 6 students who failed the test and also did not complete the assignment. What is the probability that a student chosen randomly from the class passed the test or completed the assignment? Let's fill in what we know. There's 23 students altogether. 13 of them passed the test. 14 of them completed the assignment. 6 students failed the test and didn't complete the assignment. We'll use these to fill in the rest of the table. Alright, we have 10 right here, 4, 10, 3, and 9. Now what we could do here, let's find the people who passed the test. That was 13. The people who completed the assignment, 14. And then subtract the people who both passed and completed the test. And divide that by the total amount of students, 23. We have 17 over 23. Which is about 0.74. When they ask for probabilities, sometimes you can represent it as a fraction, as a decimal, or as a percentage. A litter of kittens consists of 5 gray females, 1 gray male, 1 calico female, 2 black female, and 3 black male. You randomly pick 1 kitten. What's the probability that the kitten is gray or female? Let's write out our givens first. We have 5 gray females, 1 gray male, 1 calico female, 2 black female, and 3 black male. There's also 0 calico males. Alright, so all we need to find here are the totals. We have 4 males and 8 females. We have 6 grays, 1 calico, and 5 black. And then the total amount of kittens is 12. Now, what's the probability that the kitten is gray or female? So let's find the number of grays, 6, plus the number of females, 8, minus the amount that is gray and female, 5. And divide by 12. Get 9 out of 12. Those reduce. 3 out of 4, 0.75, or 75%.